Your filter works, then you add new rows, and they're mysteriously missing. That's not an Excel bug. It's almost always a range problem. The filter only applies to the exact block of cells it was created on. If your new data lands outside that block, Excel has no reason to include it. The fix is choosing a data structure that grows automatically. You have 3 reliable options. One is converting your list into an Excel table, which expands with new rows. Another is using a dynamic named range, so the filter source updates as the list grows. And the third is using spill ranges from dynamic array formulas, which can drive a filtered output that stays current. In the next few minutes, you'll learn how to identify which setup you have, why it breaks, and how to rebuild it so new rows are included without constant rework. Once you understand the source range, this problem becomes easy to prevent. Next step. First, diagnose the situation. A filter can be attached to a normal range or to an Excel table. If it's a normal range, Excel stores the exact address, like A1 F200. When you add row 201, it may not be included. If it's a table, the filter is tied to the table object, not a fixed address, so it usually expands. The tricky part is when your new rows are not truly adjacent. Maybe there's a blank row, a blank column, or a note sitting to the side. Excel often treats that as the edge of the list. Another common issue is pasting data that starts one row below the last row, leaving a gap. That gap breaks the current region Excel uses to guess your dataset. So the key question is simple. Are your new rows contiguous with the filtered range, and is the filter based on a table or a plain range? Once you answer that, the fix becomes straightforward. Next step. Let's talk about the most common root cause. The filter was created on a fixed range. Excel will happily filter A1 through F200 forever, even if your real dataset becomes A1 through F350. You can confirm this by selecting a cell in the filtered area and checking what the selection covers when you click inside the header row. If the border stops early, that's your limit. The fastest manual fix is to reapply the filter to the full range, but that's a band-aid because you'll be doing it again next time. Another subtle issue is when you insert rows below the range. Inserting can extend a range, but only if Excel recognizes it as part of the same list. If there's a blank row, or if the filter wasn't applied from the header row, the range might not expand. So if you're using a plain range, you need a strategy that grows with your data. Next step. The most reliable long-term fix is converting your data into an Excel table. Tables are built for exactly this. When you type in the row directly below a table, the table expands, and the filter includes the new row automatically. You also get structured references, which make formulas easier to read and harder to break. To convert, you select any cell in the data and create a table, making sure My Table Has Headers is correct. Then confirm your headers are clean, one header row, no merged cells, and no blank header names. After that, use the table's filter dropdowns, not a separate filter applied to random cells. One caution: if you keep blank rows inside the table, Excel treats them as data rows, which can confuse analysis. So keep the table as a continuous dataset, and put notes or summaries outside it. For most people, tables eliminate this problem permanently. Next step. Even with tables, there are a few ways people accidentally break the behavior. The biggest one is adding new rows outside the table boundary. If you paste data starting 2 rows below, the table won't jump the gap. Another is turning off the setting that automatically extends formulas and formats in tables, which can make it feel inconsistent. Also, watch out for totals rows. A totals row is part of the table, but it's not data, and it changes how you append rows. If you use a totals row, add new rows above it, not below it. Finally, be careful when you copy a table to another sheet and then paste values. You might end up with a normal range that looks like a table but isn't one. The simplest habit is this: always add data by typing in the first empty row directly under the table, or by pasting starting in that row. Next step. If you can't use a table, maybe because a legacy workbook depends on normal ranges, your next best option is a dynamic named range. The idea is simple. Instead of filtering a hard-coded address, you define a name that automatically resizes based on how many rows are filled. Then charts, formulas, and even some workflows can reference that name. The classic approach uses functions like index to define the last row, based on counting entries in a key column. For example, you pick a column that is always filled when a row is valid, like an ID or a date. Then your named range expands as that column grows. The trade-off is that named ranges require careful design. If your key column has blanks, the range might stop early, and if there are stray values far below, the range might expand too far. Still, for controlled datasets, dynamic names are a strong alternative when tables are possible. Next step. Here's a practical pattern for a dynamic range that's more stable than older offset-based setups. You define the start cell at the header or first data row. Then you define the end cell using index with a row count. The row count can come from counta on a key column or from match, finding the last non-blank. Counta is simple, but it counts any non-blank, including spaces or formulas returning empty text. Match can be more precise, but it needs consistent data types. The key is choosing a column that behaves like a true record indicator. If every valid row has an ID, use that. If IDs can be missing, use a timestamp or a required field. Once the name is correct, you can base downstream formulas on it, or use it to feed a pivot table source if you refresh carefully. The goal is not magic. It's just making the end of the list a calculation instead of a guess. Next step. Now let's connect this back to filtering, because Excel's autofilter is not designed to accept a named range as its source in every workflow. So the practical way to use dynamic ranges is often indirect. You either convert the dynamic range into a table-like structure, or you build a separate report area that pulls from the dynamic range and then filter that report area. This is where dynamic array formulas shine. Instead of trying to force autofilter to expand, you generate a clean output that already includes all rows. Then you filter that output with formula logic, or you apply a filter to the output range if it's a stable spill. This approach is especially helpful if your raw data has occasional blanks or messy formatting. You keep the raw data as is, and you create a curated dataset that is contiguous and predictable. Filtering works best on predictable blocks, so sometimes the real fix is building a better filtered surface. Next step, let's focus on spill ranges, because they solve the new rows problem in a very modern way. A spill range is the result of a dynamic array formula that can grow or shrink automatically. If your source data grows, the spill output grows too. You can build a spill that returns the entire dataset or returns only rows that meet criteria. Functions like filter are designed for this. You define the array to return and the include condition, and Excel outputs a dynamic list. The huge advantage is that you're no longer relying on the autofilter dropdown to decide what's included. Your formula decides, and it updates instantly when new rows appear. The trade-off is that spill outputs are formula-driven, so users need to understand where they can and can't type. You typically treat the spill output as read-only, but for dashboards, reports, and analysis views, spill ranges are one of the cleanest solutions available. Next step. A key detail with spill ranges is choosing the source array. If your source is a table, you can point filter at the table columns and it will expand as the table expands. That's the best of both worlds. If your source is a plain range, you need to make that range dynamic first, or you risk the same old cutoff. Another detail is blanks and errors. Filter can return nothing if no rows match, so you may want an if-empty fallback to keep the report area tidy. Also, be careful with mixed data types in your criteria column. Text that looks like numbers can cause mismatches. And remember that a spill needs space. If there's anything in the cells where it wants to expand, it will fail. So reserve a clean area for the spill output. When you set it up with a table source and a dedicated output area, new rows are included automatically, without touching filter buttons at all. Next step. Another reason filters miss new rows is the way Excel detects the list boundary. Excel looks for a contiguous rectangle of data. A blank column can split your dataset into two regions. A blank row can do the same. Even a single cell with a different pattern, like a header repeated halfway down, can confuse people into filtering the wrong block. So adopt a simple layout rule. Keep your dataset as one uninterrupted rectangle. Put titles above it, not inside it. Put totals to the side or below, not within the data block. Avoid merged cells in the header area. And try not to store comments or status notes in random columns that sometimes are blank and sometimes aren't. If you need notes, give them a dedicated column with a clear header. Clean layout isn't just aesthetics. It directly affects how Excel builds ranges, expands tables, and applies filters. Most filter didn't include new rows cases. Start with a broken rectangle. Next step. It's also worth separating 3 different tools people mix up: filters, pivot tables, and queries. Autofilter is great for quick slicing, but it's tied to a range or table. Pivot tables summarize, but they have their own source range that must be updated or based on a table. And Power Query imports and shapes data, but it refreshes into an output table that then can be filtered. If your real goal is analysis, a pivot table with a table source is often more reliable than filtering raw rows. If your real goal is a clean, repeatable dataset, Power Query can load into a table that expands predictably. The point is, if you're constantly appending data, you want a pipeline that expects growth. Autofilter alone is not a pipeline, so pick the tool that matches the job. For simple lists, use tables. For summaries, use pivot tables. For repeatable imports, use queries feeding tables. Next step. Let's lock in a practical workflow you can reuse. Step 1. Convert the raw dataset to a table whenever possible. Step 2. Ensure the table has a reliable key column with no accidental blanks. Step 3. Keep the dataset as a clean rectangle, with notes and totals outside. Step 4. For a filtered view, either use the table's built-in filter or create a spill-based report using filter that references the table. Step 5. If you must stay on ranges, build a dynamic named range based on a key column, then build your reporting area off that name. This workflow prevents the 2 big failure modes: fixed addresses and broken contiguity. It also makes your workbook easier to maintain because you're not constantly redefining ranges. The best sign you fixed it is simple. You add 10 new rows, and everything, filters, formulas, summaries, updates without you touching the setup. Next step. To wrap up, remember the core idea. Filters don't look for new rows. They obey their source. If the source is a fixed range, new rows can be invisible. If the source is a table, growth is usually automatic. If you want a formula-driven view, spill ranges can keep outputs current without manual filtering. And if you're stuck with old structures, dynamic named ranges can bridge the gap, as long as you choose a solid key column. If you want one default recommendation, it's this: store data in tables and build everything else from there. If this helped, subscribe for more practical Excel fixes that remove recurring annoyances. And for a quick check-in, comment with your setup. Are you using A, a normal range, or B, an Excel table? Small tweaks compound into massive performance gains. Subscribe to catch the next workflow optimization.